Welcome to Life with David. I'm David, and today I want to examine this Sencore Model FC123 fill check. What's a fill check, you ask? Well, to help us understand, let's use Mr. Peabody and Sherman's Wayback Machine to take us back to 1962. Back then, most radios and televisions used electronic vacuum tubes for detecting, amplifying, and rectifying signals. Tubes are a wear item, and they often fail. The cathodes of tubes are heated to 2,500 degrees Fahrenheit, so they will emit electrons. Heater filaments burning out because of these high temperatures were a common problem. Service calls by the TV repairman were frequent. Because the television sets were heavy and bulky, and time was money, technicians usually preferred to do simple troubleshooting in the home. This involved them bringing tools, test instruments, and repair parts with them. Small, inexpensive testers that could check for the most common failures in tubes were carried in the tool caddies of most technicians. The Sencore FC123 filament checker is one such tester. It was very cheap, costing only $3.95 in 1962 when it was introduced, compared to over $100 for a fragile, full-tube testing setup for the test bench. It is basically a continuity meter that has pre-wired tube sockets to speed the tube testing process. I inherited this device a few months ago, and I want to see what makes it tick. It's a pretty small box, held together with a couple screws. There's a socket for a cheater power cord for powering the unit from a 110-volt outlet. The unit also features a couple wires for testing continuity on other electronic components, such as picture tubes. I'd like to spend a moment on safety. There's nothing more important than keeping you and your loved ones safe. Be sure to read, understand, and follow the safety rules for your tools. Using your tools properly will greatly reduce the risk of personal injury. And always use appropriate eye, hearing, and respiratory personal protective equipment. In this video, we have some hazards that could really hurt you or worse. The unit is connected directly to line voltage. If you touch the wrong wire, you will get a nasty shock that will, at best, really hurt you, or at worst, could kill you. If you don't feel comfortable working around these high voltages, then don't. If you're following along, then you're doing so at your own risk. Now let's get started. Let's pop this guy open. 2 screws and the back comes off. Wow, there's not much here. 3 resistors, 1 neon tube, some tube sockets, and wire. All in a metal box. I'll bet this wouldn't receive a UL rating today. I drew up the schematic, and basically, line voltage is current limited by a resistor. When there's no current flow between the 2 legs, the voltage of the neon bulb is high enough to light the bulb. However, when current flows through the current limiting resistor, the voltage drops and the neon bulb won't light, indicating continuity. The tube sockets are pre-wired to common heater filament pin locations. Before I button this up, I make sure that all the resistors are functional and the neon bulb is fastened in place. I also make sure that no wires are touching. Let's try it out. I make a cheater cord to connect the unit to a 110 volt outlet. Because I don't have an isolation transformer, I verified that there was no current path between the line cord and the metal case. It's good, so let's plug it in. The neon bulb glows, which indicates no continuity. When we plug in a vacuum tube, the neon light goes out, indicating continuity of the heater filament. This doesn't mean that the tube is good, it just means that the heater filament conducts electricity. This tester will find obviously failed tubes, but not weak ones. However, this was often enough to identify the tube needing replacement and get the television working again. If all the tubes tested okay in the television with this meter, the chances were good that it needed to go to the shop for more detailed testing. You could do the same test using an ohm meter, but as you can see, it takes much longer, and time is money. Thanks for joining me today. We took a little trip back in time to look at a piece of vintage field electronic test gear. Since I don't do a lot of tube work, I doubt this will see much service. However, it's cool to have in my test instrument collection. If you like this video, please give it a thumbs up. If not, give it a thumbs down. And leave a comment or suggestion for things to do. I hope to do more of these videos, so please subscribe and click on the bell for notifications of new videos. Let's get together next time for another day in Life with David. See you soon!